Okay, on this one, let's discuss the problem application of Pythagoras theorem, still on the chapter of trigonometry. On this problem, it's much even more easier because you're given the sketch. You only have to calculate your unknown and then answer the questions that follow. And the first question is, of course, your unknown, which is the value of k. Okay, let's get to do the question. It says in the diagram k is to 1 is a point in the second quadrant and is √5 units from the origin. Okay, we can see that R is a point on the positive x-axis and obtuse ROP is equal to theta. Calculate the value of k. Value of k is the x-coordinate of p. We have the radius, which is the square root of 5. We also have the y value 1. Now let's do this. And therefore, this is way much easier. Why? Because we have to simply calculate the value of k. So I'm going to say x squared plus y squared equal to r squared. And my x is the value of k, so I'm going to square k plus my y is basically 1 all squared, which equals to r squared is the root of 5 all squared. So k squared obviously will be equal to, it's going to be 5 minus 1 k squared, which equal to 4. Put the square root to get rid of the square. I therefore have k, which equals to plus minus 2, right? But we have to choose. Look at the question. This implies that our k in the second quadrant, look at your x should be basically negative, because going that direction we have negative x values and that way positive x values. So we have to choose here. We therefore choose k equal to, we have to choose minus 2. That's the value of k for 2 marks. So obviously the mark would be for substituting into the correct formula, the Pythagoras theorem formula. Could also say Pythagoras th, or you could say th. We're done at the value of k. This was 5.1. Now 5.1.2, we have 5.1.2. number A, without using a calculator, calculate the value of tan theta. Now check 5.1.2. we are now required to calculate the value of tan theta. Look, our tan theta in this case should be equal to tan is opposite, which is y, all over adjacent, which is x. Therefore, what will our tan theta be? Our tan theta will simply be the y value. We have discussed that the y value is basically equal to 1. And what about the x value? X value is equal to minus 2. So we have y, which is 1 over our x. In this case, it's going to be minus 2. And therefore, the tan of theta will be minus 1 over 2. Then what about b? When we work out number b, we are required to work out the cos of 180 plus theta is therefore going to be equal to the cos of, we have 180 degrees plus theta. Let me just do this. This is the same as when we reduce cos of 180 plus theta. You can write your cos diagram 0 to 360 degrees revolution, 90, 180 and 270. So let's see. we have to reduce this cos 180 plus theta, 180 plus we move counterclockwise, and for minus we move clockwise. So for cos of 180 plus theta, we go to 180 simply because we have 180 plus moving counterclockwise, and theta, under the assumption that it's an acute angle, we have the angle lying in the third quadrant. That's 180 plus theta. So cos is negative here because we have all students taking coffee. Therefore, cos of 180 plus theta, it simply means I'll be having negative, because cos is negative on the third quadrant. I have minus cos of theta, which is equal to minus x over r, which equals to minus my x in this case will be equal to, look at my x. My x is basically going to be minus 2, which is the value of k, all over the root of 5, which is the, in this case, it's our hypotenuse. Therefore, I'll be having 2 over the square root of 5 as my final answer.